Okay. Data in the real world is messed up. So let's look into why we should clean the data. But before that, I want you guys to pause the video, read through the slide, and then listen to what I have to say. Okay, now let's start. The factor I'm taking into consideration is the factors that lead to heart attack among human beings. Some factors we might take into consideration in this study is gender of the person, age, income of the person annually, the person's house, distance from work, occupation, stress levels, sleeping hours, eating habits, etc. etc. So we can have some missing values in there. Like in the gender column, some values can be missing. If so, then it's difficult for us to come to a final conclusion and say stuff like, there is a general tendency that men have a higher chance of getting a heart attack than women with a 10% chance. Why we can't come to such a conclusion? Because we have missing data in our data set. So what do? Do we totally ignore these missing values or not? If our data set is large enough, we can actually ignore this data. But it will be creating some biasness. But if our data set is very small and we remove these rows, there will be a lot of biasness in our final conclusion. Say, in the factor of annual income of the person, some people might not like to disclose the information provided while they have very high salaries or low salaries for personal reasons, let's say. Or say the entry operator might not have recorded some incomes of some people. So either way, what are we going to do? One way is we can replace those missing values using the mean or mode, or we can choose to ignore those rows. If our data set is large enough, we can do that. And also if our choice is that. Then next problem up we have is normalization. Sometimes two columns we consider don't have the same scales. Say the person's house worth is given in pounds while the annual income is recorded in dollars. So we can't compare those two. Then eventually we have to convert maybe the worth of the person into dollars or the annual income of the person into pounds and compare while having the same scale. And also we normalize when say the number of children the person has can lie in numbers 0 to 10, while the annual income of the person might go from a range of 10,000 to about say 100,000. Then those two scales are not compatible, and if we come to a final conclusion, it will be more biased towards the annual income because those numbers are quantitatively having a higher value than the value of number of children of the person. So what do is we can convert the annual income of the person to a scale of 0 to 10, or what we can do is convert both the annual income of the person and the number of children of the person to a scale of 0 to 1. Then another thing that comes into disturbance in data is duplicate values, where the same person's information might be recorded twice or more times. Then we might think, okay, this same record is entered 50 times maybe of the person with different email addresses or while they were at different occupations, then it's not fair. And our final end result will be very biased. So we have to remove any duplicate entries. Also, we talk about outliers. Say an age of around 250 is recorded. Practically, it's not bit possible the living age of person going up to 250, it's an outlier. And also, say an age is recorded -10, so we have to choose to ignore those values. Now we can ignore those values because we can see it with the general naked eye. While studying some data in data science, there might be factors, many of those, which we can't see through the naked eye. Then what we do? We might use concepts like nearest neighbor, where beyond the 10th nearest neighbor, we ignore those as such. So those are the deformalities in data. See you again in the next video. Bye for now.